Okay, so today we're going to use probability to make predictions. This is done a lot in doing a survey or polling people to what they like, and then taking that probability of someone selecting a certain type of ice cream and then comparing it to a bigger population and predicting how much ice cream to buy. So we use probability to make decisions and predictions all the time in everyday life. For example, if a weather person forecasts a high chance of rain, we may decide to carry an umbrella to work or school. So that is making a prediction and then following through on it. Can you think of other examples of where probability is used to make a decision or prediction? The probability of an event occurring can be used to set up a proportion to find the number of times an event is likely to occur. So this is rolling a dice, and if you're going to roll a 5 or a 6, that's 1 out of 3. And then if you roll the dice 27 times, that's times 9, that's times 9. 9 times out of 27, you're going to roll a 5 or a 6. So it's taking that probability of doing a simple event and then looking at what the probability would be if you did it many times and making a prediction. So this is a spinner. Joe spins the spinner on the right. What is the probability that he'll land on a yellow? Well, yellow is 1, 2, 3, 4, 5. 1 out of 5 is yellow. 1 out of 5. Okay? 1, 2, 3, 4, 5. Yeah. And if Joe plans to spin the spinner, let's say 30 times, about how many times can he expect to land on yellow? So I pick 30 because it's a multiple of 5. So 5 times what is 30? It's times 6. And 1 times 6 is 6. So if he sat there and he were to spin the spinner 30 times, he could expect to land on yellow 6 times. So why didn't I choose 28? Because 28 doesn't evenly go into 5. But so this is the way. Now, if I wanted to find out the probability of landing on green, red, or orange, so the prediction of green, red, or orange. And so that's 3 out of 5, and I'm going to spin the spinner 50 times. So that's times 10 times 10, so 30. So 30 out of 50, so that's 60% of the time. And if I spin 50 times, 30 of them, I'm going to land on these 3 colors. 30 of them. The other 20 times, I'm going to land on these. And this is, of course, theoretical. If you actually do the experiment, you may come up with different numbers. Okay, this is the way it's used in business. A store sells cases to hold CDs. The table shows the capacities of the last 200 cases sold. The store is going to order 1,600 and 200 more CD cases. Use probability to decide how many of each type of case to order. So the 24 CD case. So 24 CDs is 70. So 70 out of 200, because it tells me the total. If I add all these up, it adds up to 200. So 70 out of 200. Now I'm going to order 1,600 more. So what is the probability to decide how many to order? What is my prediction? Well, this is times 8, and so this is times 8, and 7 times 8 is 56, and then bring over the 0. So 560. What does that say? I need to order 560 of the 24 CD cases. So of the 1,600. And then the 96 CD case is 52. So 52 out of 200, and that's going to 1,600 again. That's times 8, And 52 times 8, I've got to do the math on that. 416. So what does that say? I need 416 out of 1600 to be the 96 CD case. Players use a spinner to move around a game board. Suppose the spinner is spun 40 times. 40 is my hole over here. Predict how many times the spinner will land on Get a Clue. Get a Clue is 1 out of 1, 2, 3, 4, 5. So this is times what? Times 8. And this is times 8. So I predict that 8 times it's going to land on Get a Clue during the game. So this gives you an idea of how to set up the number, the prediction of what the times that you're going to do it, that you're looking at, and what your part to the whole is, and to have your probability to set it up.